One of our core tools that we, to a certain extent, will use as sort of the foundation for almost everything we do is this very basic idea of a conditional probability chain rule. I'm just generalizing this a little bit. For any kind of joint probability of multiple variables, we can always, pull out a subset of our multiple variables, and you can imagine taking kind of the basic expression for our joint probability, and then you can imagine sort of multiplying and dividing by the size of the set of whatever set of random variables we're interested in, and then just recognizing that this, in effect, is our definition of a conditional probability, and this is our definition of an unconditional probability. So basically, this just has this form of being able to pull out some particular variables of interest, and everything else becomes the condition, the conditional probability of those variables multiplied by the unconditional probability of the remaining set of variables. And if you just repeat that process over and over and over again, so now, for example, I take this joint probability and I extract some subset of variables from it, you can see I've got a chain rule here that will basically expand a joint probability as a product of a bunch of probability terms, basically with, you could think of it as having, you could start with an unconditional probability of one variable, then conditional probability of the next variable conditioned on the first variable, and so on and so forth.